like I think we did it once and then did it again. I feel like the whiteout makes me think that there was an issue or a strange thing about it. Yeah, I found it. Oh, I see what it is. I'll remind you or show you what it is. I bet you didn't read the problem closely. Like I said, this is one that, so I have whiteout because I think I did it once and then realized I didn't read the directions very well. So if you look at the problem, let me put it up on the board. So in number 25, it says, describe the possible lengths of the third side of the triangle given the lengths of the other two sides. So here's what makes it tough. It's 2 feet and 40 inches. The units are what makes this one tough. Because I can't use them the way they are, because they're 2 different units. So it just so that's probably all it was. But let's still talk through it. So like I said, I think I had whiteout because I thought that I did something wrong and like it didn't answer the book's answer. So what do I have to do with this? I have to make all of it the same, either inches or feet. I think making it inches a little bit easier. I know that 2 feet is 24 inches. And so then 40 inches. So we use those two numbers rather than 2 and 40. So that's what made this one tough and why you probably made a mistake here. So you check the, and I'll still go through it, but so we can assume we have a third side and we don't know what that is yet. Again, we replace the feet with inches. So we check it and see what if X and 24 were the shortest sides? And then what if 24 and 40 are the shortest sides? So we do those two outcomes. And then this would be 64. And that would be inches. So if you chose to use inches, that would be inches. If you change it to feet, you either have the decimals or fractions. That's tricky. I wouldn't give you anything that is trying. It's almost usually it's trying to trick you other than you had to make a mistake. All right. So if you're good on that, otherwise, any other questions? Is that it? So let me get you guys your notes for today. Like I said, this is a short section of notes, pretty straightforward. Nothing too fancy or difficult. So we get our last section of notes before we get ready for a test. And again, my plan is to just review for one day because we've already done the chart for this chapter. We might look at the chart a little bit more. I'm sorry. Okay, then one more guy. So we'll review Monday and then test on Tuesday. So just a heads up on that for kind of planning ahead. So again, if you look at notes, not very long notes today. There is a warm-up question if you guys want to look at that first of all. isn't asking us to write an inequality. It's asking us to figure out which of these side lengths makes sense for this triangle. There's only one that should work, that would fit into the range, that would work for this triangle. So there's a number of ways you guys can go about this. You could just do a guess and check. You could set up an inequality. It's kind of up to you guys what seems the fastest to you. And it's really what you notice first compared to like me saying what would be the fastest procedure. What did you guys try here? Ellen, what did you do? Because I see you one circle. Did you set up the inequality or did you just try different numbers?
Yeah, I set it up. I did 8.8 plus 38.3 is bigger than question mark.
So you did 8.8 and 38.3, and then you did what?
Is bigger than X.
Okay, so she's checking, what if those were the two shortest sides? And checking to see it's gotta be bigger than X. So when we add those, we get, of course, decimals, 1, so 37,
I got
47. Yes, thank you. So this is saying X has to be less than 47.1. So that automatically eliminates the top choice, right? How do we get rid of the other two? Get rid of the other two. We need to get it down here. Did you just guess because that one was close then?
I did 8.8 plus X.
Okay, yep, so yeah, you did that. So she did another inequality. Then she checked this one, take away 8.8. So X has to be greater than, what is that, 29.5, is that right?
Yeah.
Yeah, so that automatically eliminates these two. So that leaves us with the 39.3. You also could have just tried it. You could have just done 27.3 plus 8.8 and checked. 29.3 plus 8.8 and checked. 47.3 is the biggest one, so you would add these together and check. So you can try different values as well. It's whatever seemed the fastest to you. So on a multiple choice question, although you don't get partial credit for showing work, if you get the answer, multiple choice question doesn't care if you show your work. So if you're able to do it another way that makes sense to you, that's fine. So being efficient is kind of more one of the bigger things with multiple choice. So we're going to talk about this thing called the hinge theorem today. And like I said, there's been years in the past where I've actually skipped this section just because we ran out of time, or typically I think this falls around Christmas time because of the every other day lesson thing. So sometimes if I can fit this in, I do it. If I can't, it's not the big end of the world. But I thought it was an okay thing to do on a Friday. And then that gives us a chance to review with everyone to come back virtually. Most students will be back virtually Monday, and that we're virtual on Monday, and then we'll review and test. So I thought it was an okay day to do another section of a lesson. So we will take a break somewhere in here, but it's going to be a pretty fast section of notes. So what this is saying, and this is essentially going to seem a lot like yesterday, where, again, if I grab my yardsticks here, So I'm going to grab my yardsticks here, and we talked about this yesterday, that if this angle is smaller, that distance is going to be smaller. If this angle is bigger, that distance is going to be bigger over there. So if I don't change these side lengths, that's always going to hold true. So if I'm talking about one triangle, that works that way, but if I'm talking about two triangles, so if you guys look, I have these two triangles, and let's say, so again, they're kind of telling us these side lengths are the same. So like if this is 7, this is 7. If this is 5, this is 5. So those distances aren't changing. So what it's saying is if this angle is bigger than this one, I should be able to make a conclusion about this side. Now this only works if we have the two equal sides to begin with. So if the sides don't stay the same length, this no longer works. However, if two sides of one triangle are congruent to two sides of another, we have these two equal sides. So I basically have side, side. That will give us a relationship between this included angle will determine the relationship between these two sides. So if I have this A and then I'll call this one F here, there's going to be a relationship between those lengths. It's kind of wordy, sorry. The included angle between the sides can tell us the relationship between the lengths. So we know that angle A is greater than angle F. A is bigger than F. That means for us then that the side across from angle A, I should probably just use the letters, BC then has to be greater than GH, sorry. So the side across from that angle has that relationship. And then we're going to write this down as the converse too, so the other way goes as well. So the reverse of this also works. So I know these side lengths. I know this is 12 and this is 8. Again, I have these two equal sides. I don't know what, they don't say what those specifically are, but we know they're equal. That means that angle across from that 12 and that angle across from the 8, I can make a conclusion about that. So I should know, what about angle L? Whoa, what just happened there? Double circle there. What should I know about angle L compared to angle R? Yep.
It's greater than.
Yeah, so L will then have to be greater than R. So if JK is greater than QP, then angle L has to be greater than angle R. The biggest thing is it must be the included angle between the congruent sides. I should say the congruency. All right. do you guys want to finish notes and take a break, or like finish notes and go outside, or do you want to take a break now? What do you guys think? Just finish them. All right, I've heard an opinion, so I'm gonna do that. We'll finish them, and then maybe if you guys really wanted to, I don't know, if my team up outside, just outside and work. I don't know. Would you rather do that, or would you rather stay in? Stay in. What's it?
Doesn't matter.
Doesn't matter. You guys are all so agreeable. Like trying to pick a place to go for dinner. My husband. All right. The worst is when he's like, choose a place. I'm like, I don't care. And then he'll give me some options. I'm like, I don't want to go any of those places. Like, I swear he like wants to like quit at that point. So sorry. Okay. So they want us to compare these measures. And again, like I said, this is a pretty easy lesson here today. So it's nothing too insane or difficult. So it really is kind of assumptions are okay in this case. So you guys look, we have a situation where we have two equal sides, or these two sides are equal, and then that shared side is also equal. So what does that allow me to conclude about AD compared to BD? Yeah, so we just put our inequality in there that it wants to eat the AD because AD would be bigger. Little alligator or your fish or whatever that is. Pac-Man. All right. This one is set up a little bit differently. So see if you guys can see what's going on here. So in this case, we have an equal side. And then again, we have this equal side in the center. So the angle we're talking about here, and if it helps to kind of draw these separately. So here's 5.5, we have this and this. And then we have, going this way, we have 5.1. So what do I know about this angle up here compared to this one down here? What do I know about angle B compared to angle D? So this one's across from 5.5, this one's across from 5.1, yep. Yeah, so this is gonna be bigger that way. And notice the B is the center of the angle, so that's how we know that. All right, so looking at our last example, well, that's crazy fast, but it's okay. So this last one, find the range of possible values for A, little a, and they have that here. So again, we have equal sides here that are shared. And they tell me LDM is 141. They tell me MDN is 9A plus 15. What do I know about those two angles? How would we use this to set up an expression or an equation or inequality? Yeah, Ellen?
141 is greater than 9A plus 15.
Yep, again, if this angle is across from that side, 141 has to be greater than 9A plus 15. So we're able to solve for A, so I'm going to move this 15 over. So this is going to be, what is that, 6, 32, is that right? What's over here then?
14.
What's that?
14.
14, thank you. Okay. Now I want to mention something else though about this. I think we have to do this other end of it. Let me. Oh, maybe that's all we have to. The only other thing that maybe you want to say is that, so A has to be less than 14. You You might want to say that A also has to make sure this is a positive angle. So you might want to say that 9A plus 15 has to be greater than 0 because we can't have a negative angle. You might even want to say it's got to be greater than 90 degrees, but we shouldn't have any issues with, I don't think we actually have to do this for our, but I just wanted to mention it. Negative 15. So obviously A has to be bigger than like a negative 1 point something. So, well, this is okay for your answer that A has to be less than 14. All right, actually, just to get finished up completely with our chart, do you guys want to pull your chart out from last time, the purple, I believe it's purple. So there's the purple chart last time. Does anyone not hear me do that or need a copy? I don't have it filled in, but I have it like a blank one. All right, so let's see, I know I want to write the inequalities on here. Let me make sure that one of the things, maybe just something we forgot to write last time, or I forgot to give you guys, with the mid-segment, remember that these two are going to be parallel. So DE would be parallel AC. Important to note. Now, I met with a student yesterday online. We were just talking about trying to be able to notice things about these different types of triangles. And so being comfortable with the mid-segment, so it bisects each side and it's parallel. Perpendicular bisect, the name has two things in it. So it's both perpendicular and it bisects. So it could go like kind of across the triangle and not actually go to a vertex. So perpendicular and bisect. So like DE here is our perpendicular bisector. So you have to look for both of those pieces. It has to be both perpendicular and bisect. And again, we have that over here. Just trying to make sure I have everything. We did this kind of fast the other day for our Kahoot, so I want to make sure I have everything. Circumcenter, yeah, it's equal to all the edges. Angle bisector. So in a triangle, it would just look like this. That's all an angle bisector has to do. And altitude orthocenter. So then the thing I want to add is that triangle inequality that we learned about yesterday. So talking about the side lengths that make sense for a triangle. So I just would add that other piece to our chart. And then this chart should be something over the weekend, just look at it. If you look at it for 5 minutes on Saturday and Sunday, it's gonna be stronger in your memory if you did it. So it means that, like if you're like, I never know how to study for math, make yourself redraw like a perpendicular bisector. Do something to help get this in your memory stronger, because you guys need to know these vocabs. Like being able to identify like what a median is, and that you'd be able to locate that. Yeah.
What's the difference between a median and a mid-segment?
So very good. So median and mid-segment. So this is a median, mid-segment's on the top. Does anyone else want to help with that? What do you notice is the difference? Yep.
Not parallel.
There's not a parallel line, so there's nothing parallel. There's nothing parallel in the median. There's another thing. The mid-segment's the midpoint of two sides. So if you look, the median's the mid-segment or the midpoint of one side, whereas you go back to mid-segment, it's the midpoint of both sides. So the mid-segment, I always think of it as like, if you were like, I don't know, building a sandcastle, building a cake, something like that, and you just chop off the top. So it's like there'd be like 2 layers, would be mid-segment versus median. And the median always goes back to the vertex. So the fact that it touches the vertex is maybe helpful. Most of these, angled bisector touches the vertex. So kind of watching out for some of those things, being comfortable with that. I like questions like that, so thank you. Make sure you ask them, and if you need like clarification on like deciding that. So then altitude should touch a vertex as well. So the only one that doesn't have to touch a vertex is the perpendicular bisector in the mid-segment. So those typically aren't going to touch a vertex except if it's a special case. All right, so the thing I'm going to add to this is the triangle inequality. This is what we talked about last class. So the triangle inequality says any 2 sides added together have to be bigger than the third side. Any 2 sides added together have to be bigger than that third side. And then I guess maybe, I don't know if you really need this, is remembering the angles of a triangle add up to 180. So hopefully you guys know that. Whoops, that's not. So not forgetting this, you'll use this a lot. Let's check. All right, so again, test is going to be on Tuesday. Bring questions Monday on things you're struggling with from this chapter. Those of you guys who are virtual, most of you guys will be back Monday, so we'll have time to review together, make sure you guys are feeling ready for the test, and then testing on Monday. If those of you guys who are virtual need to see me before then, we can always, like, we want a meeting, or we can have you guys come in on the AR or something for a little bit of extra review. So the test on Tuesday is the plan. It's a 4-day week, hopefully for you guys, as long as you're caught up on homework. All right. So you have the rest of the time to work on the homework. Those of you guys online, short lesson here. We're probably gonna